this is a walkthrough on how to use the ratio test to determine if a series is divergent, convergent, or inconclusive. So here we have the series a sub n equals 3 to the 2n plus 1 over 9 to the n times the square root of n. So according to the ratio test, the limit as n approaches infinity of a sub n plus 1 over a sub n, the absolute value of that is our expression for the ratio test. And if r is less than 1, the series is convergent. If r is greater than 1, it's divergent. And if r equals to 1, it is inconclusive. So let's perform the ratio test. So a sub n plus 1, we just plug in n plus 1 for every n. So if we plug in sub a n plus 1 here, this becomes 3 to the 2n plus 3, because 2 times n plus 1 is 2n plus 2, then plus 1. So you have a 3. Then this is 9n plus 1 times the square root of n plus 1. Then when you divide a sub n, which is this fraction, is the same as if you were to multiply by the reciprocal of this. So this is the same as this piece times 9 to the n times root n over 3 to the 2n plus 1. Then here we can use our exponent properties, and we can rewrite 3 to the 2n plus 3 as 3 to the 2n times 3 to the 3 cubed. Then this is 3 to the 2n times 3 to the first power, so the 3 to the 2n cancels with this 3 to the 2n. So we just have 3 to the third, 3 to the first, so that's gone. So we have a 9 up here, 3 squared up here, and then the same thing here, right? 9 to the n plus 1 is the same as 9 to the n times 9, and we have 9 to the n here, so those are gone, and leaving me with a 9 here. So the simplified form becomes 3 squared times the square root of n over 9 times the square root of n plus 1. And since we know that if n is going to infinity, they both have the same exponent, or they both have the same power. Yeah. So it's just the coefficient, right? So in this case, it's going to be 9 over 9. That equals 1. And because r equals 1, we know the series is inconclusive. So we can type that in where r equals 1, and therefore the test is inconclusive.